In Chapter 2, Section 1A, we're going to focus on linear equations in two variables. So this is when you have, we've already talked about a linear equation, which is, for example, we've done something like 2x plus 3, and that's a linear expression, right? Because x is to the first power. And sometimes we've done, we've had an equation that says like, 2x plus 3 equals 10 or something like that, where you're actually just going to solve for x, right? But now we're just going to talk about generic equations where we have a, y equals 2x plus 3. And so you're going to end up with two variables in your equation. This x here to the first power dictates that it's linear. So this slide really focuses on the three types of equations, or the three forms in which we can write a linear equation. The first form is slope-intercept, and we use this one for graphing. Okay, the reason we use it for graphing is because when we graph, the slope is critical information, and if we happen to just have a point on the graph, as soon as we know the point, we're able to graph. So if we have something like y equals 3x plus 2, and we know in slope-intercept that the plus 2 part here, that's where the graph crosses the y-axis, if you remember this from algebra, right? And then the m is your slope, which is 3 over 1 here, in this problem that I gave you here, 3 over 1. So I know if I'm going to graph this, I just go up 3 points and 1 over, or down 3 and 1 back, or so, it's kind of crooked, but, and again, we can quickly graph. So again, if you can isolate or identify 1 point on the graph and the slope, it's super easy to graph. And so that's what slope-intercept gives you. A point on the graph, the y-intercept, and the slope. So again, for graphing, it's great. Point slope, we use a lot in Algebra 2. We're going to be using it a lot in our next lesson in Part B. And so again, but this is the equation that represents it, okay? In here, you're basically going to be given, you're going to use 1 point, that's what point means, and that would be this y1 value and this x1 value, and you would be given a slope, okay? And then using the slope and that point, you're going to be able to plug those three values in. Going back to this other formula up top, slope-intercept, you're going to be given, or you're going to have at some point, right, you're going to have the m and the b value are what you plug in here. So those are where you're going to have numbers. And then the last one is standard form. And in standard form, notice the x and the y are on the same side. The c is on the other. And there are some important features with this as well. You're going to have this a value. Whoops, not like that. You're going to have an a value, a coefficient there. You're going to have a b value, and you're going to have a c value. Okay? Neither a, b, or c, they cannot be fractions or decimals, and your x cannot be a negative. The coefficient in front of x, the a, has to be positive. And so again, we're going to utilize them in different times, but what I want you to kind of pay attention to is to notice that in every one of these, in the equation, you're always going to have the letter x and the letter y in it, unless it's a horizontal or vertical line. But you're always going to have, you're going to leave those x's and y's in there. And where the numbers are going to be is the m and the b, or the m and the x1, y1, or the a, the b, and the c. Okay? And again, we'll go into a lot of details on this in the future. So I guess the first thing is we've been talking about this m value, or slope, right? And so again, we want to kind of recognize what is the slope. And so remember, if you happen to have a, here's your coordinate plane, here's your y-axis, your x-axis, and the slope of a line is how steep the line is. So in other words, a line could be incredibly steep like this, or a line could be, very flat looking, much less steep. A line could even go, steep, but in the other direction. In other words, from left to right, the graph is going down. That would be a negative slope. And even amongst all of this, you could even have a vertical line that goes up and down, or you could have a horizontal line that goes right and left. So lines take on all different steepnesses, and the slope is that steepness. The slope is referred to as change in y over the change in x. In other words, it's the rate of change of y over the rate of change of x. Another thing that we use instead of the word change in, we use delta. And delta, it's a Greek letter, and it represents change in something. So delta y over delta x is a quick way to write it. Some people like to write it as the rise of the graph over the run. Again, notice that y is your up and down axis, and that's why rise is your up and down change. X is your side to side or your horizontal change, and so that's why your run is your side to side change. And the last way you could do it is you can just say, you find the y value of one point and the y value of another, and you subtract it. And again, a subtraction is the difference or the change in the y's or the x's. So then we go to the x-intercept. The x-intercept is where the graph, it has it right here, where the graph intersects or crosses the x-axis. So it's like the x-axis intersection, okay? And wherever you go through the x-axis, let's say, you go through the x-axis here at x is 2, right? This ordered pair is going to be 2, 0. So notice that your x-intercept, you can list it as a number. The x-intercept is the value 2, okay? I like to write it as an ordered pair. It's at the point 2, 0, right? So this is like assuming this line, for example, does this, okay? That's where the line crosses the x-axis. That's the x-intercept. And notice that the y value is 0 at the x-intercept. Now, notice here, if I go to the y-intercept, let's say it's here at -3, right? This is 0, -3. So again, I can say the y-intercept is -3. We also label the y-intercept the letter b in a linear, so b would be -3. Or I could list it as an ordered pair. And again, unless I'm saying b is -3, I prefer it as an ordered pair. And notice that your x value is 0 when you get to your y-intercept. Okay, so again, just some basic things. So every line has a numeric slope that you're used to. It's going to be 1, 1.5, 2.5, -3, and whatever. But vertical lines and horizontal lines have a very odd slope compared to everything else. So let's kind of think about what the slope of a vertical line would be. So a vertical line is a line, let's say we go here to 3, and a vertical line, we're going to do one right here through the number 3. Okay, and if I pick some numbers on this graph, right, on this thing, I know like this point right here is 3, 0. This point here, let's say, is 3, 2. Let's try this. If I go down here to like, let's say -4, that would be here. So this would be 3, -4. So notice in this vertical line, every x value is always 3. X equals +3. Notice that the y value, it's all the different y's, but notice one thing. This graph never intersects the y-axis. There's no y-intercept in this graph. There's only an x-intercept. And so whenever you have a vertical line, okay, your equation is always going to be x equals whatever this number is. Okay, so it's going to be x equals 3 in our example. And there's no y in your actual equation. Okay, so x will always be 3. You basically just go down and you plot all these points to infinity, infinite numbers of points where x is 3. If I ask you for the slope, remember the slope is the rise over the run, for example, or remember that it's the change in y over the change in x, or we write it also as y1 or y2 minus y1, x2 minus x1. Either way, let's just pick 2 points. Let's pick here 3, 2, and let's pick this point here at 3, 0. And so we're like, okay, the change in y's. Well, it goes from 2 to 0, and the other one is 3 minus 3. And so I'm like, oh, 2 over 0. Well, guess what? Can you have 0 in the denominator? No. Remember that 0 in the denominator means an undefined value. And so when you have a vertical line, it's undefined, or we also can say it has no slope or undefined. Either words are fine. I prefer to say undefined, but it's either way. Now also remember that your slope is your rise over your run, and notice that from one point to the other, you have a rise. You know, it either goes up or down, but it does go. There is a value here. But notice that there's no run from one point to the other. The graph doesn't go to the right or to the left from one point, and that's why when there's no run, it's undefined. Now, contrary to that, you might have the scenario where you have a horizontal line. So let's say we're here at 2, right? And we have this horizontal line like this. Notice that this might be, you know, -4, 2. Notice this here is 0, 2. And notice here this is 3, 2. And so you're like, oh, in every single one of these points, the y equals 2. Well, that would be the equation for that, y equals 2. There's no x in your equation because guess what? X is always, x is all numbers, and y is always going to be 2. And so you would just say y is 2 in this equation. Again, notice there's no x value. Now, when we talk about our slope and we try to figure out, again, rise over run, notice that this from one point to the other, let's say I was going to go from -4, 2 to 0, 2, there is no rise, right? There's no up or down change. So the rise is 0. The run, yeah, there's a change here in my run. So if I want to, figure out what the change here was, I might say, well, what was the change from here to here? And I'll say, okay, my x went from 0 minus -4, which means 0 over 4. But either way, no matter what my denominator is, if my numerator is 0, my whole fraction is 0. And so my slope for a horizontal line is going to be 0, not no slope or undefined. Because again, so just think about it. When you have no run, as of up here, okay, when you've got no run, it's no slope. When you have a run but no rise, it's 0. Because, again, a 0 in the numerator represents a fraction that equals 0. Okay, so if we go to graph these, right, notice that all of these or most of these or all of these really are in, we're going to convert to slope-intercept form. And again, slope-intercept form is our preferred for graphing. So in this first problem, I know that my slope, remember that we've got y equals mx plus b, right? So my m is 2/3, and my b, or my y-intercept, is 1. So how I start here is I go to 1, and that's my first point. That's where the graph crosses the y-axis. Remember, this is my y-intercept. And then my slope is 2/3, so I actually will go up 2 and 3 to the right. A rise of 2 and a run to the right of 3. And I can also, because it's plus 2 over plus 3, well, what other rise and run would give me a positive 2/3? Well, minus 2 and minus 3, right? So I could also go down 2 and back 3. Down is negative, left is negative. Either way, once I have just a couple of points, I'm able to kind of connect my dots, and I have my line, and this goes to infinity. Every line is an infinite set of points. Also notice and pay attention that equations of a line, no matter which form, I got to go back to that, but they're always going to have the x and y in it. If an x is missing or a y is missing, you know it's going to be either vertical or horizontal. So let's go to the next one. We go here. We see that our m value equals -4, which is the same as -4 over 1, and our b, or our y-intercept, is positive 1. So again, I'm going to start at 1, but now I know my slope is -4, 1. So my rise, I could say, is down 4, 3, 4, and my run is 1 to the right. Down 4 and positive 1 over. Or I could switch it. I could say, okay, it's plus 4 and a minus 1. So it's going to be up 4 and 1 back. Either way, notice that it's all on the same line, and once I graph a few, I'm ready to graph my line. So this is y equals -4x plus 1. Whenever you're graphing multiple things, you should get in the habit of labeling the line that you draw with the correct equation, okay? All right, so let's go to the next one. Now notice in the next one, we get here and we don't have y isolated. So again, all we have to do is divide by 3. So I'm going to divide by 3. And I get that y equals 2/3 x minus 1/3. Now it's a little bit of a pain to graph negative when you have these fractions, okay? However, negative 1/3 is the y-intercept, so you know it's kind of here. It's between 0 and 1. And I know that my slope is 2/3. And so again, my slope is going to be up 2 and to the right 3. So 1, 2, 1, 2, 3. 1, 2, 1, 2, 3, something like that. Or I could go again down 2 and back 3. And so it should look something like this. Okay, so this is y equals 2/3 x minus 1/3. Now notice that the green line and the blue line are parallel. We're going to have this conversation later, but notice what is the same and what is different in these equations, right? Notice that parallel lines have the same slope. They just happen to have different y-intercepts. So their starting points are in 2 different spots, but they're going to follow the same pattern and slope, steepness throughout the whole graph. Then we keep going to, let's go to, let me get a different color here. Okay, so let's go here to 3y equals 5. I'm going to divide both sides by 3, and notice that I'm going to get y equals 5/3, which is the same as 2 and, or not 2 and 2/3, it's the same as 1 and 2/3. And so what it says is y equals 1 and 2/3. That means that every single y value is always going to be 1 and 2/3. No matter what my x is, my y is always going to be 1 and 2/3. That means that I've got this horizontal line. Okay, so y equals 5/3. And again, it's just asking me to graph here. And let's do black. And then the last one, divide by 2, and I get x equals 1/2. And so again, x is 1/2 is like right here, which is, again, here x is 1/2. At this point, x is 1/2. And again, you're going to notice, I should have not done black, but anyway, you're going to notice that this black line is x equals 1/2. And notice that it's a vertical line. Okay? So there we graphed all of our graphs. And again, we use this formula really for graphing equations. It's the easiest one. Now we get some other ones, and it's like, all right, well, how do we graph these, right? So notice this is in standard form, to start, right? This is standard form. This one can be. So again, when they're in standard form, there is a way to graph, okay? And what we do with standard form, if it's in true standard form like number 6, one way to do it is using intercepts. In other words, we say, well, if I can figure out where it crosses the x-axis and I can figure out where it crosses the y-axis, then I have 2 points, and through any 2 points, it's easy to draw a line. So how do I find those 2 points, right? Well, I can find the intercepts. So for this one, I think one of the easiest ways to do it is to say, okay, well, what happens if x is 0, right? This will cancel. I'll get 2y equals 6 and y equals 3. So when x is 0, y equals 3. That's one ordered pair that I was able to find. So when x is 0, y is 3. I just found the y-intercept. Remember, we talked about that. Whenever you find the y-intercept, x is 0. We also talked about then to find the x-intercept, you make y equal to 0. So now I'm going to find x by making y equal to 0. So that'll cancel, and I'll get minus 3x is 6. And when I divide by negative 3, I get x equals negative 2. So when x is negative 2, y is 0. So again, negative 2, 0 here. That's my x-intercept. And then guess what? Now I can draw this line. Keep it going, whatever. I know it's not a perfect line, but this is the line of negative 3x plus 2y equals 6. So I graphed this one using x-intercepts. And so sometimes I find that that might be the easier way to do it. And usually I do it when it's in perfect standard form and I know that the numbers are like divisible and super easy. But truth be told, most of the time that I have something like this, I'm going to switch it over to slope-intercept form. So like number 7, I'm definitely going to switch it to slope-intercept. So I'm going to subtract 3 from both sides first, right? So I'm going to get minus 3x minus 3 equals 2y. And then I'm going to divide everything by 2. And so I'm going to kind of switch the order just because I like the y on the left. But it's going to be y equals negative 3/2 x minus 3/2. And so I know that my intercept is minus 3/2, which is here. And I know my slope is minus 3 over 2. So I can either go down 3, 1, 2, 3, over 2, like that. Or I could go up 3 and over 2, like that. And either way, I'm going to be able to get my line. I know my lines aren't great today, sorry. And this is the line of, I can, use my new formula if I want, or my new equation, or I could use this original equation. But either way, it's line for number 7. So again, when I get here to number 8, notice there's only one variable. So again, I know this is a horizontal or a vertical line. I might not remember right off the top of my head. But either way, I'm just going to add 1 to both sides. 4x equals 6, divide by 4. X equals 6 over 4, or 3 over 2. And so x equals 3/2. That's 1.5 again here. Let me get a different color. And again, I know that this is going to be a vertical line. This is x equals 3/2. And again, they're only asking me here for a graph. If I were to ask questions like slope, then, you would have to kind of use this to figure out what the slope of each line is. So again, for this one, I know the slope is going to be undefined. So anyway, I keep going here. Let me go to this next one. And once again, I am going to put this in slope-intercept form. So I'm going to subtract 2/3 x from both sides. So minus 2/3 x plus 7. And I'm going to divide everything by 4. So divide by 4, divide by 4. So let me show you how to do that a little easier. So I'm going to get y equals, now negative 2/3 divided by 4 is the same as negative 2/3 times 1/4, which means negative 2 over 12, or negative 1/6. So negative 1/6x plus 7 over 4. And so that would be my graph. And again, that's kind of a pain to graph, but whatever. My y-intercept is 1 3/4, so about here. Doesn't have to be super precise. And my slope is negative 1/6, so it's going to be either up 1 and back 6, 1, 2, 3, 4, 5, 6, or it's going to be down 1 and to the right 6. Something like that. And so again, it'll look whatever like that. Okay? And so that is the graph for number 9. Let's just do that. All right, and then we've got one more graph to do. There's a lot of graphs on this page, so I think I'm going to start erasing, or maybe not. Let me just leave it there. Let me do black. So then here, again, I'm going to divide everything by negative 3. And I'm going to get that y equals 2/3 x plus 1/3. Be careful with a negative over a negative is a positive. So again, I'm going to find my y-intercept is 1/3, so it's about here, okay? And my slope is positive 2/3, so it's going to be up 2, 1, 2, 3 to the right, or down 2 and 1, 2, 3 to the left. Whoops, terrible. But that's the graph there for number 10, okay? And I know it's a little bit messy, but you can kind of get the idea. So when we come to this slide and we see that it's asking us to find the slope, what we're going to be doing here is we're either going to have to, obviously the equation that makes it the easiest to find the slope is y equals mx plus b, Because once we have it in this form, we know what our slope is. It's the coefficient that's in front of the x. And so what we need to do is anytime we see an equation with variables is we just convert it to slope-intercept. So in 11, it's already in that form, so we know m equals 3. In 12, we're just going to solve for, we're going to move the numbers over. Notice there's no x here, okay? So we get 2y equals 6, so y is 3. So notice this is a horizontal line, and in a horizontal line, you have a run, right? But you have no rise, so your slope equals 0 here, okay? When we go to 14, we see again an equation, and so we know what we're going to have to do is divide everything by 2, okay? And so we're going to get y equals, now we've got 2/3 divided by 2 is 2/3 times a half, which is 2/6, which simplifies to 1/3. So 1/3 x minus a half. And so we know that m, again, is the coefficient in front of the x, and so it's 1/3. When we come to number 15, right, we see another equation. It's in standard form, but again, we need to know our slope, and so we're going to have to subtract 2x from both sides. We're going to get 3y equals negative 2x plus 5, and then we're going to divide everything by 3, and we get y equals negative 2/3 x plus 5/3, and we know that this is our slope, negative 2/3, okay? And that's it for that. So again, this is equations. We just have to manipulate them to solve for y. That'll put them in mx plus b form, and that coefficient in front of the x is your slope. When you're given 2 points, you're going to have to use the slope formula. Remember that to find the slope, we find the m equals the change in y over the change in x. And the formula for that is we just do y2 minus y1, x2 minus x1. Now, the only reason we say y2 and x2 and all that is just because we want to differentiate. Like this x and this y go together, so they're, let's say, 1. This x and this y go together, so we call this ordered pair 2. But in the end, it doesn't matter which one you put first or second. So how I do it, to be honest, is I put one on top of the other, like that. And then when I go to solve it, I just do the top y minus the bottom y. So 3 minus 7 over top x minus bottom x. So negative 4 over 0, which is undefined or no slope. So I know that this ends up being, this would end up being a vertical line, okay? And then when I come over to this one, the same thing, okay? I put 5/3 up top, and I know my slope is my change in y over my change in x. So 3 minus 3 over 5 minus 4, 0 over 1, and that's 0. So I know that this is a horizontal line. And I know it because notice, look, my y is the same in both. This equation would be y equals 3. In this other one, my x was 4 both times, and so that equation would be x is 4. But again, I wasn't looking for the equation, I was looking for the slope. And here we're finding slope again, and we're going to utilize the different strategies. If it's in standard form and if it's in the form of an equation, we're going to convert it to slope-intercept. And if it's in the form of ordered pairs, we're going to use the formula for slope. So again here, we're going to subtract 3x from both sides. 4y equals negative 3x plus 5. And then we're going to divide by 4. So y equals negative 3/4 x plus 5/4. And so we know that m equals negative 3/4. Now also notice that I never add the x in when I write the slope. The slope is never x. It's the coefficient in front of x. If you put m equals negative 3/4 x, it's incorrect, okay? The m is the slope, and the m does not include x, okay? And then we come down here again, and we isolate x because it's our only variable, so x is 2. Again, this is a vertical line, and this has no slope or an undefined slope because, again, it has a rise but no run. Our denominator would be 0, which is unacceptable. And then these, we're just trying to find the slope here. So again, remember that I just do I write this first one up top. It doesn't matter which one, and then I just do change in y over change in x. And so I know that my change in y is 2 minus 5. My change in x is negative 3 minus 4. So I get minus 3 over minus 7, which is positive 3/7. And there's my slope. And be very careful with your negatives. So I know my slope again is change in y over change in x. Negative 2 minus negative 5. Negative 1 minus negative 3. Plus, plus. It's 3. Plus, plus. It's 2. And that's my slope. So again, just work on that slope formula and work on manipulating equations to solve for y whenever you need to.